Hi all, welcome to this, the first video in our new topic, which is Biosphere. Now, for a very brief outline, what are we going to be looking at in this topic? Biosphere focuses on the formation processes and the properties of three distinct soil types, and we're looking at podzols, brown earths, and clay or tundra clay soils. So we're looking at how are these soils formed, and what are the main characteristics of each of these soils. Now, we're going to be starting by going through some of the background terminology and the stuff that we need to be familiar with before we can get into the soil profiles. Now, this is maybe a wee bit different from some of the other more generic background stuff I've given in some of the other topics, where this stuff is fairly fundamentally important, and we need to make sure that we've got a firm grasp of all of this information. Now, when we're talking about the main factors that influence how soils are formed, we are looking at a variety of different things. So you can see we have got 8 factors that we look at here. We've got the parent material, so what are the rocks underneath the soil? And when we're thinking about that, we're really looking at what is the impact these rocks have on that soil. Do the rocks give their minerals into the soil easily, and can those minerals then be used to boost the fertility or something like that of the soil? What vegetation do we have on top of the soil? Are we talking about we're in an area of deciduous woodland, where we've got a lot of leaf litter every single year, and that's going to have a very particular effect on the fertility of the soil as well? Or are we looking about maybe an area of coniferous woodland, where again we're going to get a lot of needle cover, but it has a very different impact on the soil that it's in? Now, living organisms, we are realistically talking here about what we will refer to as soil biota, or living things in the soil. And these are really going to be responsible for any mixing that we see of the soil. Something when we look at the soil profiles in a bit more detail, we're really focusing in on some of them on how well mixed the soil is. And that moves nutrients about, and that has a big impact on how effective that soil is in terms of allowing things to grow on it. Now, with climate, we are really looking at how wet is an area and what is the temperature in that area, because both of these things can have a really pronounced impact on some of the chemical reactions that occur in the soil, and they have a big impact on the type of soil that we have. Now, relief marries in a little bit with climate. Obviously relief, slope of the land, shape of the land. We're really looking here at what is the shape of these slopes, and then how is that going to have an impact on water movement throughout the slopes. So are we going to see slopes that are very, very steep, and as such we're going to see water moving through them quite frequently? Or are we maybe at the bottom of a valley where we're going to see a lot of water gather, and that would have a very pronounced and a very different impact to if we don't have water gathering in an area of soil? Now, with time, we are really just trying to make the fact here make the point, that soils take a long time to form. For a soil to really fully establish itself, we are on the time scale of 100,000 years or so. So we need time for soils to form in any depth and to really establish the different types of soil that we are going to be discussing in this topic. Now, natural events is obviously hugely varied, but we're talking about things like, do we see regular and pronounced periods of flooding? Do we see volcanic eruptions? It could be a variety of natural events that could have a big impact on different soils. Now, obviously, the UK hasn't seen a volcanic eruption in quite some time, but we do see pronounced periods of flooding, and that has an impact on how soils form. And the last soil forming factor that I'm going to mention here is human activity. What have we physically done to the soils? Very particularly in areas of agriculture, where we are introducing different chemicals to soils to have a very particular impact, and normally to improve fertility. What have we done to a soil that's going to have a big influence on it? Now, all of these factors you will mention to different extents dependent on the soil type that you're asked to discuss. So you won't necessarily always discuss how prominent parent material is or not, but with some you will. So it's important that we are aware of all of these, and we're aware of when to apply them as is relevant. Now, what processes have an impact in biosphere? Now, we've got 5 processes we're going to talk about here. Now, one of them is something that you'll be familiar with, that being weathering, but the other 4 that we're going to be talking about, leaching, capillary action, decomposition and humification, and translocation, they're new, and we're going to have a wee talk about what these things mean, and then you'll hopefully see how they could become prominent as we start to get into some of the soil profiles. Now, first, leaching. When we're talking about leaching, this is really to do with rainfall, and it's where rainfall exceeds the rates of evaporation in an area. And that's going to mean moisture is going to move down through a soil. It's going to move through it, going down towards its parent material. Now that's going to drag nutrients down deeper into the soil, and the big effect of that is it makes the soil less fertile, because the plants that are growing on the surface of the soil have to work harder to get those nutrients, and they have deeper root systems or things like that, which they might not have. And if they don't, that means that you're going to see a more limited range of plant material on top of a soil that's heavily leached. Now, capillary action is the exact opposite of leaching. This is where evaporation is in excess of precipitation, and that means moisture moves up towards the surface, and that brings nutrients back up through the soil, and it makes them more available for plants to use. Now, it is worth stating at this point, as it won't be a huge surprise, in the United Kingdom, capillary action is reasonably rare. It's much more common for us to see rates of precipitation exceed rates of evaporation, but it can and it does happen. Now, decomposition and humification. Now, decomposition, I reckon most of you will be familiar enough with. And it's literally, from biology or any other subject area. We're talking about the breakdown of plant-derived material into its constituent parts. Now, humification is very similar. It's the same kind of core process that we're talking about, but we're looking at it in a very slightly different context. We're looking at it to make a type of humus. Now, not to be confused with dip. This is humus that we see on top of a soil profile, and this is an area of broken down organic material that is very, very important for plants to grow. And we've got three types of humus that we look at. Now, we've got mull humus, so if we've got areas of largely deciduous woodland in plants, we see mull humus forming, and this forms a very alkali humus, and it breaks down very, very quickly because we tend to have a lot of soil biota in these areas as well, because they tend to be a bit warmer, and it tends to be very, very fertile. Moor humus is found in areas of coniferous woodland, and again, this creates a very, very acidic humus that breaks down slowly because these areas tend to be colder. We tend not to have as much soil biota to do mixing and stuff like that as well, and this tends to be slightly less fertile. And moder humus is just one we've got in here as well, and it's in the middle. You don't have, as with so many things, you don't have, mull, moder, or moor humus. It is a continuum, and it varies slightly. But moder is just in the middle of mull and moor. Now, weathering is weathering. We've discussed weathering multiple times in different areas. We are just looking at rocks and minerals being broken down by natural things like air, wind, etc. Now, we do split it down here into two very slightly kind of different subsets of weathering, where we have physical weathering, which is just, things being literally broken down into smaller and smaller chunks. And we've got chemical weathering, where we're talking about the chemical composition of something being altered by a particular chemical process. Now, last, translocation. Now, this is a fairly flash term for something that is quite straightforward, but it does bring in a couple of new terms in here as well. So, translocation at its core is the movement of material between the different horizons in a soil profile. We're going to look at an exemplar soil profile in a moment, and you'll see what I mean when I'm talking about these horizons. Now, normally, we see material moves from the top of a soil profile down, and it moves, and that way we're talking about this upper horizon, so where it is up at the top, we call this the E horizon or the alluvial horizon, and this is where maximum leaching or alluviation, the process exiting, is how I always remember this, is it's E for an exit, takes place. So we see material move. Now, it could be minerals, it could be nutrients moving from the top of the soil down. Now, as it goes into the next horizon and it settles out there, we see this lower horizon called an alluvial horizon, or I always remember I for in. So it's, the E horizon is the exit horizon, and your I or your alluvial horizon is your in horizon. And this is where you get maximum accumulation of these nutrients and these minerals that have been moved down. Now, we're going to spend the last couple of minutes of this video, we're just going to look at an example soil profile, and then we're going to have 3 further videos where we'll look at our 3 soil profiles individually, and we'll discuss them in a little bit more depth. Now, when we look at soil profiles, I've mentioned soil profile horizons quite a lot in today's video, and this is what we're going to just establish what these are. Now, the horizons themselves, fundamentally, are just areas where we see noticeable differences between some of the characteristics of the soil. And in some soil types, the horizons are more pronounced than in others. So, what are we talking about? Now, largely speaking, you can see we've got a couple of different ways of determining what the horizons are here, but we'll move through them. So our O horizon, or your very, very top area. So this is generally considered part of topsoil, and this is where we've got, a lot of vegetation here. You've got leaf litter right on the very, very top, so you've got areas where whatever has fallen out of trees and bushes and all the rest of it gathers up. And this, if you go and you walk through an area of woodland, this is what you're walking on. Vegetation and leaf litter. Now, immediately beneath that, you've got areas where this leaf litter has started to decompose, and it's starting to ferment, and it's starting to undergo chemical changes, which allows the nutrients that are within that organic material to become available to plants in the soil. Now, below that, we've got the humus layer that we've talked about already, and that could be a mull, a moder, or a more humus, depending on the particular climatic area and the particular plants that we have above us. That'll alter what type of humus we have there, but this is where our humus is. So these are all in our O horizon, and this tends to be quite a thin horizon. Now, when we move into the A horizon, and this is more often than not what people mean when they refer to topsoil, it's an upper area in the soil, and it tends to be the area where most of the nutrients are gathered. And they're gathered here because they've just came out of this humus layer, and they'll have been washed down slightly into this A horizon, and if you've not had huge amounts of leaching or anything like that happen, they're going to remain in that area. Now, the B horizon, or subsoil, is an area where the texture of the soil becomes a lot more coarse. This is where weathering, physical weathering, can become quite important, as if there hasn't been a lot of it, you can have reasonable sized chunks of soil or rock or different things in this area. And this might receive some nutrients, but if it is going to have nutrients in it, they've got there via leaching. Now, the C horizon / bedrock is another term that's up here, is parent material. This is where the soil, we are at the very, very base, where you're going from soil into rock. And your C horizon is going to be characterised by having a lot of soil with big chunks of rock kind of strewn throughout it. And then as you go into bedrock, we are talking about just transitioning from areas where you have soil and rock to just rock. Now, I'm going to draw this video to a close here. As I say, in our next video, or the next 3 videos are going to be hopefully a lot shorter in duration, and we're going to look at each of our 3 soil profiles in a lot more detail. So until next time, I'll see you guys later.